Okay, these bottom ones go a little bit shorter. So we're going to go ahead and start with the slope. Change in y over change in x. Now this first part of the table isn't filled out, but you can kind of look for a pattern and fill it in. So it went from 7 to 13 to 19 to 25. Can you tell how much it's adding every time? It's adding the same thing each time. So sometimes whenever you're looking to see how much it adds, if it's not easy to see in that part, you can look for different parts that it may be easier, like here from 13 to 19. It's pretty easy to see that they're adding 6. And you just check to see, well, is that what the rest of it did? It is adding 6. So something was here and then they added a 6 to it. So if I think about what number can I add a 6 to it and end up with a 7, well, that would be a 1. Okay, so I've already saw that my change in my y values across the bottom was 6. So write that on your ratio for slope. 6 goes on the top. So that means if these were on a graph, they would have a rise of 6. I'm going to look for my change in x values. It is adding 2 across the top. So I'm going to reduce that, and I'm going to say that my slope, so I can write this on this blank right here, is 3. 6 divided by 2 gives me 3. Now before, we had wrote out the equation y equals mx plus b to be able to find our y-intercept, but sometimes you're going to be able to look in your table and actually just see the y-intercept. On one paper that we did earlier this week, we wrote out the y-intercepts, and they always had an x-coordinate of 0. So whenever you see the x number of 0 in your table, they are giving you the y-intercept. So my y-intercept is just 1 because I could see it right here. So the equation that represents this one would say y equals 3x plus 1. Okay, on the next one, to get my slope out of a table, I am doing the change in the y values over the change in the x values. We've got a missing link right here, and this time, if you're looking for a pattern, it's actually subtracting 20 every time. So something minus 20 was 120. So if I need to go backwards, I'm just going to do the opposite sign. So I'm going to be adding 20 to get 140 in that empty spot. Okay, so I already labeled on the bottom that the change in the y values right here was a negative 20. Make sure you do include the sign. If they were subtracting, I need that negative value. The change in the x values is adding 5. So I'm going to put a positive 5 on the bottom. You always want to reduce your slope. So negative 20 divided by 5 is negative 4. If I need the y-intercept from a table, and you can see that we have the x value of 0, because if you visualize what it would be to graph that, if I needed to graph this point, 0, 40, 0 is telling me don't leave the y-axis, I need to stay there, and then I just have to go up, way up high to that 140. So if the line, oh, this one had a negative slope, so it's going to be going downward. We said negative 4. But it's crossing, so the y-intercept, I can see in the table, is 140. So the equation that represents this table is y equals negative 4x plus 140.